In this video, I'll be going over how to make a CRUD API with Flask and connect it to Postgres. We will be utilizing an ORM called SQLAlchemy, which will allow us to communicate with our Postgres database. SQLAlchemy will allow us to easily query data from the database without writing the SQL query. Sounds convenient, right? I will be utilizing Docker to run a Postgres instance or container instance, and you can also get a GUI like pgadmin4 or db for it to see what is going on in the database tables when we create them. I will be using db for community, which is free. By the end of this video, we'll be able to create a backend using Flask that will allow us to create an account, log in, and provide a JWT token, which will authorize a user, which they'll have to provide for each route in our application. And the user will then be able to create a fund, update a fund, get funds, and delete funds, because we'll be creating a fund manager. Let me give a quick demo so you guys can see it in live action. So here I am in Postman. I have an instance running, and what I'm expecting for sign up is the first name, last name, email, and password. So you can see my first name is Tech, my last name is with Geo, my email is geo@aol.com, which I haven't seen anyone use AOL in a long time, but that's fine. And the last name is password, which is subscribe, which if you guys don't mind, go ahead and subscribe for more content. And if I press send, we should see the message user is created, which is right here. The status code is 201 created. Nice. Now I can go here to log in, and if I press login with these credentials, which is geo@aol.com, and the password subscribe, you can see that a token is returned, right? And if I go to get funds, and I have some old funds, but it's different now, you can see that right here I am utilizing a variable called JWT, which when I go into login, it's simply just retrieving this JWT token and putting it into a variable called JWT, and I'm passing it as an authorization header, which I'll show you later in the video. But now we're able to go in and grab the funds, but currently there are no funds. If I go up here, I see that the data is an empty list, there are no funds, and the sum is equal to 0 because there are no funds. Now if I go into post, a JWT token is still required, so I still pass in the JWT variable that's holding the token that was retrieved when I logged in, and passing it through an authorization header. And now if I want to create a fund, which right now is holding a value of 550, which I'll change, I'll put 600 or get 600. And if I press send, we can see that now it was created on Sunday and the amount of 600. Nice. Now, say for instance I made a mistake and I want to update it, right? Same logic, right? You still need an authorization header with a JWT, because this JWT token is holding information regarding the user, right? It knows what user it is based on the token that was created when you logged in. So I'm able to grab the ID based on the user, and I'm able to update the funds based on the ID that was stored in the token. So this token is very important when authorizing and authenticating a user. So right back in the body, we know that when we did the get, we see, or if we go back to the gets and press send, we created a fund amount of 600, and you can see that the sum is now 600. But we made a mistake, so now we want to change that to 700. All we got to do is specify the fund ID. So we know that the ID, when we retrieve the funds, the ID was 1. So if I go back to the puts, right, I could just specify the ID that I want to update, which the ID of the fund was 1. So I got to specify the fund ID here in the URL and the amount that I want to update it to. So I want to change it from 600 to 700. And if I press send, I can see that it was updated. If I go get the funds again, I can see that the sum is now equal to 700 and the amount is 700. I can also create another fund. Let's say it's 550, right? And the ID is now 2. If I get the funds again, it is now, the sum is going to be 1250 or 1250, and you can see the different amounts or the different funds being stored. And last but not least, deleting, you still got to send the token. And if I specify ID that I want to delete, so I'll change the ID here to 2, because we do know that we have 2 funds that are stored for this user. So if I send a ID of 2, it's going to show a message of deleted. And if I go back to getting it, I can see that it was deleted, and now I just have the ID of 1 and the sum is just 700. So this is what we're going to create in this video. So stay tuned, and we're going to create a nice CRUD application using Flask. Alright, so the first thing we want to do is set up Docker. So first, make sure that you have Docker installed on your computer. If you have a Mac, then you should see like a little whale up top. If you don't, then it's fine. You probably open up the GUI and then check that it's running. So you can see that there's like a little green section at the bottom that shows that the engine is running. So once you see all of that, then we can run our Docker command to actually create our Postgres instance. So I'm just going to paste in the command here. So it should be docker run -- name. You can give your container a name. In this case, I'm going to call it Postgres -db. And I am going to provide it some variables, some environment variables. So if you go on to the Docker official Postgres image documentation, there are some variables that you can provide to give it values. So if you want to provide the Postgres user on creation, you could. So in this case, I'm providing a variable called Postgres_user and making it equal to user. And I'm also providing it a environment variable of Postgres_password, which is going to be equal to password, which probably should be more secure. But since this is only for demo purposes, then I'm going to keep it simple. But essentially what this is used for, when we need to log into our Postgres server, we can utilize these variables. We can utilize this user for the user name, and we can utilize this password for the password. And the next thing that we're going to specify is the ports. So I'm just specifying where I want the ports to be exposed on locally. So inside of the container, Postgres is going to be exposed on 5432, but on my local machine, I want it to also be exposed on 5432 so that I can log into Postgres locally utilizing this port. Now this first port could be anything you want to be exposed on the local machine. So if you want to go into Postgres using 5434 locally, you could do that, but I just want to keep it the same. But you also got to make sure that the port is open and it's not being used elsewhere. Then I'm running in detach mode and specifying the actual image name that I'm going to use to create the container, which is Postgres. Like I said, I'll leave a link in the description to the official documentation of the Postgres image, but we'll be utilizing that official image to create this container with this username and password that we provided, and it's going to be exposed on 5432. But like I said, you can choose whatever you want. Just know that the default port for the second port has to be 5432 because internally that's what the Postgres instance is being exposed on. So press enter and we should see some hash, and if I go to the GUI, we should now see that there is a Postgres container being ran, and the port is 5432 and the status is running, so we're good to go. And like I said before, I'll be using dbeaver, which is going to be essentially a SQL GUI, so I can see what's going on with my tables as we start to create them. You can use pgadmin 4, I know that's a popular one, but dbeaver just works better on my device, so I'll be using that. And now I have dbeaver open, and hopefully you guys can see because it's not allowing me to zoom, but let me close this out. But if I go to the top left and press new database connection, it's going to allow me to choose the database management system that I'm using, which in this case is Postgres. And here I can specify the host, which in our case is going to be localhost, the database, which by default Postgres creates a database of Postgres, so we'll be utilizing the default database. The port right here, I'll be using 5432 because that's what I created when I created the Docker instance. But whatever port that you use to be exposed locally, just put this here in this port section if you are using dbeaver. And I just got to specify the username and password here. So my username is user and my password is password. And then if I press finish, it should connect to that Postgres instance. And currently there are no tables, but you can see that there's already a default database created called Postgres, which we're connected to. We're going to create some tables to be placed into this Postgres database soon when we create our Flask application. But at least now I know that we have a functional Postgres instance running, and we are able to connect to a database using the credentials that we created. All right, so now I'm in VS Code in this empty folder called funds, and this is where I am going to create the Flask application. So let me open up a new terminal. All right, and the first thing that I want to do is I want to create a virtual environment. This is very important, right? Because this will allow us to download the dependencies within that virtual environment. I don't usually like to download dependencies globally, because versions always change. So downloading in a virtual environment will allow me to have more control over the dependencies that I install. And if I need to share those dependencies or the versions, it's easy to do that because it's all within this virtual environment. So to do that, if you don't have virtual environment installed on your computer, all you got to do is do pip3 or pip install virtual env. I already have it, so I don't need to install it, but if you don't have it, then go ahead and pip install virtual env. And then to actually create one, all I gotta do is do python -m venv and then give a name of the virtual environment, which I usually just keep the same of venv, but this could be anything. It could be virtual whatever, right? But I'm just gonna call it venv. And it's going to create it for us right here. We can see the folder pops up, and all we got to do now is just activate it. So to do that on a Mac, you just do source venv, which is just the folder structure, bin activate. And what helps me remember is if I go into the folder structure, I go into bin, I can see there's an activate script in here, so I just know that it's utilizing that to actually start up the virtual environment. So whenever I don't remember the actual directory, I just open it up, go into bin, and I see, oh, there's activate. And to know that it's activated, you usually see the name of your virtual environment on the left here in parentheses. So cool, now we have the virtual environment activated. Now we can actually start downloading the dependencies that we need. And really, we just need 3 main ones, and I'm gonna copy and paste it here. Oops. And did I break something? Let me clear this out. Quit. I guess I can't be lazy, so let me actually type it out. pip3 install Flask, and I'm gonna do Flask SQLAlchemy, which is gonna be the ORM that we're gonna use to communicate with the database, and we're gonna do PyJWT, which we're gonna use to return our JWT back to the user when they log in. All right, cool. It looked like it successfully downloaded. We're good to go. Now, let's do the initial setup of our application. What we're going to need to do is create an init file, which will be the initial file for application. So we're going to do the setup there, such as importing the proper dependencies and creating the connection between our application and the database that we just created. So I'm going to do new file, 2 underscores, init, 2 underscores again, .py, right? And now let's start importing the dependencies. So I'm going to do from Flask, import Flask, which we just installed. And I'm going to do from Flask underscore SQLAlchemy, import SQLAlchemy. Perfect. And then now I'm going to define the app, which is going to be Flask. It's going to be the name of the module, so underscore name underscore. And then I want to define an instance of our SQLAlchemy, right, that we just imported. So there's going to be a reference so that we can communicate with the DB. So I'm going to call this DB equal to SQLAlchemy and open up the parentheses, and that's it. Now, for SQLAlchemy to communicate with our DB, we need to configure it to take the DB URI. So like I said before, Postgres by default creates a database with the name of Postgres, which we saw when we connected it to dbeaver, or if you had pgadmin, you probably saw there's a Postgres database already created, because once we create a Postgres instance, it's automatically created, right? We can create our own database if we want to, but in this case, I'm only going to use the default one. So keep that in mind, because we're going to need that when defining the Postgres DB string, right? Because we need to connect our app with the Postgres instance running. So to do that, we have our instance of app, right? But we need to define the configuration. So we're going to do app.config, and what we're going to define is the SQLAlchemy database URI, right? So SQL underscore, and I already misspelled something, so that would have probably caused me some pain in the future, but I've seen it just now. So SQLAlchemy underscore database underscore URI, and what we can do here is set that equal to the Postgres DB string. So the structure of it is we got to give it the database management system that we're going to be using, so which is in this case is Postgres SQL or Postgres SQL, and then it's a colon, 2 front slashes. It's going to be the username that you created or that you provided when you created the Docker instance for Postgres. In my case, I use the environment variable and I defined the username to be user. And then you're going to have to put a colon between that and provide the password that you used. So in my case, I just use password, right? And then you have to put, the host. So in my case, the host was localhost because I created the instance to run locally. Then you got to define the port that is running on locally. So in my case, it's 5432. But if you use a different port, then you can define that as well. And then you have to define after the front slash, you have to define what database you're trying to connect to. And like I said, we're going to be using the default database that Postgres came with, which is Postgres, right? If you had another one, if you create another database called demo or tests, you will define that here. But in my case, I'm using a default database, which is called Postgres because it comes with Postgres. Now that we have this configured for SQLAlchemy underscore database underscore URI, we can now finish the initialization of this DB instance by doing db.init app and pass in the app itself. So now we have established a connection between our application with this app, right? And if you have Visual Studio Code, you can hover over this method and it will give you some information regarding some of the config properties that you can provide to give information regarding SQLAlchemy. So there's some like engine options, echo, bind, but in our case, we just defined the database URI. And just so you guys know, it's not good convention to just pass the string all willy-nilly like this. You should probably put it in a .env so that you can use the environment variables to inject the variables into the string. But just to shorten this video, I passed it directly, and because we're using a local instance, it's not too bad. But say for instance you were hosting this database somewhere else, like in the cloud, you don't want everybody to have access to this query or this string or this database string. So make sure that you use a .env and you're injecting properties such as the username, password, and the database name by using a .env. You don't want to put it directly. You don't want everybody to have access to that. So just a security warning. So let's create the models for our application. So models are essentially the structure of tables we want to create in the database. We'll be able to define each field and the data type associated to that field. We can even establish relationships between the tables through models. So we'll be creating 2 tables, one for all the users and a table for the funds. We'll establish a one-to-many relationship between the user and the funds because one user can have many funds. So first, the user. Let's first create a file called models. So we'll do models.py and let's start creating the user table or the user model. So I want to import this DB instance that we just created because, like I said, this is going to allow us to communicate with the database. So I want to import or from the parent directory, right? I want to import DB. And let me save this actually. Because if I right click and go to definition, it's going to bring me right to this definition right here, which was initialized with this database URI right here. So There's that. And then now I could just do class users, right? And do db.model, because essentially what we're doing is defining this as a model. And now we can start defining some of the fields of this user's model. And we can even change the name of the table if we want to. So we could do __ table name _ and set this equal to whatever we want this table to be called. So I'm going to do capital U users, right? And then now we can start defining some of the fields. So the first field that I want to define is ID, because every user created in this table or this model or utilizing this model, the first field that I want to create is the ID, because every user created should have a unique ID, because we should be able to differentiate between each individual user when they sign up. So I'm going to set this ID equal to, and to create a column, because we're going to be using this model to create a table in the database, and each field essentially is a column in the database. So to do that, or to define the column and its type, we could do db.column, right? And now we can open up the parentheses and define what type of column is this. So this is going to be a db.integer, right? This is going to be an integer type, and I'm going to set this equal to the primary key, because this is what's going to specify that this is a unique instance for each individual row that's inserted into the table. So we're going to set this to be the primary key, and I'm going to set that equal to true, because this ID will be the primary key, because this is what specifies on how a user can be unique for each insertion. Then the next field is going to be the first name, and we're going to set that equal to db.column, and I want to set this data type, and I forgot the n. I want to set this data type to be a string, so I'm going to do db.string, open up the parentheses. And the cool thing about string is that we can pass in a integer to specify how long we want this string to be, so the maximum length. And I'm going to put this as 100, because if we don't, it's going to allow us to put any length of the string. And first names can only be so long, and we don't want people to put millions of text for their first name, because first of all, that's a waste of space, and second of all, that don't even sound real to have a million a first name that's a million in length. So define a max length, it'll save you from the headache. And I want to make sure that this is required, so I want to put nullable equal to false, because I don't want any null values for this field, right? Whenever you insert into a users table, I want to make sure that it is non-nullable, is an actual value. And if you want to do some other checks, like there should be a minimum amount of text and all that, then you can do that as well, or you can do that in the logic when you handle the request, but we'll talk about that later. So I want to do this for multiple other fields. I want it to also be a string, so I'm going to cheat a little bit and copy and paste, and I'm going to change this one to be last name, right? And I'm going to make this a little bit longer, right? Because I've seen some very long last names, so I'll set this last name to be the max length of 200, but I still want this to be non-nullable, meaning I don't want any null fields for last name, so it's required. And the next one is going to be password, right? I'm going to make this password of length 250, because we are going to be hashing the password, meaning whenever someone logs in, we don't want to put the password as clear text into the database. We want to make sure that the password is hashed, so in the case that for some reason the database is compromised, the user's password is not wide open to be seen, right? It's hashed, and it's not in a format that other people will understand, right? You would have to decode it, which you will also have to have access to a secret key, which we'll also go over coming later in this video. So I want to set that to nullable equal to false as well, because this is required as well. We need a password, right, for each user. And then one more time, I'm gonna do email, and that's also gonna be a string, and I'll set this still equal to 100. This one though, I want this to be unique, so I'm gonna add another additional parameter, and I'm gonna set unique equal to true, because I don't want to have users with the same email multiple times. I just want one instance of that email, right? So ID is going to be unique, but as well as email. You can even create a constraint in that case as well, but it's not really necessary. because ID in this case is going to be incremented each time. Whenever a user is inserted into the user's table, it's going to increment. So it's going to start at 1, then it's going to go to 2, then it's going to go to 3. We shouldn't have a user using the same ID multiple times, right? It should just be once, and it should increment from there. But with email, I want to make sure that it's only that email is only being utilized once, right? We shouldn't have users with the same email multiple times. So to make sure that it's unique, we just make sure that unique is equal to true. And I don't want it to be nullable, so I set this equal to false. And then I also want to know when the user was created, so I'm going to have another field called created _ at. I'm going to set that equal to db.column, and then we'll do db.datetime, right? It's going to store the date and the time, and I'm going to set the time zone because I want the time zone to be included, so I'm going to set that equal to true. And in this case, I want to set it to be server default equal to func.now. So whenever the field is being injected, or whenever a user is being created, I just want to grab the current time, right? I shouldn't have to set it myself. The server will just default to doing the current time when it was actually created. And I'm going to have to import func. So from SQLAlchemy.SQL import func. Nice. Another cool thing that we can do with this class, right, is to create a representation of, when we print out, or if we have to print out an instance of this object or instance of this class, we could print out a representation. So if I do 2 underscores REPR and another 2 underscores, and I pass in self and colon, I can return how I want this to be formatted when printing out an instance of this class. So I'm going to use a string formatter, and I'm going to do user, and I'm going to inject the self dot first name. It could be email if you want, or it could be any of these attributes or anything that you want to insert into the string, but I'm just going to return it as the user, and specify the first name. You can even probably inject the ID as well, just to make it a little bit more useful, but it's really up to you. And I got to do self.id, actually, self.id. So cool. So now when I print out an instance of this class, then it'll print out this representation of the object using this string. Cool. Now it's time to create the funds model, right? Because we saw the funds model in action. We should be able to create one using the amount, but it also needs an ID, and we're going to also establish a relationship between the user and the fund. So let's get started. So let's do class, and let me go down here, class funds, and this, and with an S. Let's do db.model, open up the colon, 2 underscore table on this table name, I'm struggling here, and equal to funds. And let me make it a little bit nicer by putting space in between here. And that's just defining the table name of the table that's going to be created using this model. And then I'm going to do ID is equal to db column, and it's going to be the same, db integer, and I'm going to set the primary key to this ID, and it's going to be good to true. So it's the same logic. Whenever we insert into this funds table, I want to make sure that it has a unique ID, and it's going to be incremented every single time we insert into this table. So we set this ID equal to the primary key. And then the second thing that we saw was, the fund should have a field for the amount. So we'll set the amount equal to db.column. And usually when it comes to dealing with money, the best data type to use is numeric, right? Because we're going to do numeric. And there are 2 parameters that we're going to pass here. First is going to be for precision. Precision is just the number of digits in a number. And the second one is going to be scale, which is the number of digits to the right of the decimal point in the number. So for USD, usually there's only 2 decimal places after the decimal, or after that decimal point. So I'm going to set the precision to 10, because that's the maximum amount of numbers that I want before the decimal point. And then after the decimal point, I want the scale to be 2, because usually it's like, 150 cents or 120 and 25 cents. So I want the max to be 10 digits, and then the decimal place to be 2 digits. So that's for precision for the first one, and the scale. And then another field I'm going to create is the user ID. All right, I want to know the user that's associated to this fund. So when I create this fund, who does this fund belong to? So I'm going to store the user ID for this specific column, and I'm going to do db.column, and I'm going to match the column to be the same as the ID of the user. So in this case, it's going to be db.integer, and I got to establish the relationship, because this is a relationship that I'm establishing between the user and the funds table. So I'm going to assign this to be the foreign key, because this is utilizing a value that is a primary key of another table. So that's the foreign key, and the ID that we're going to be using to store in this user ID right here is the primary key of user. So that's why we're utilizing foreign key here. So, and we're going to specify that primary key by doing users.id, because this is the ID of users and it is the primary key. Nice. And then I'm just going to steal this last line, because I want the same logic, right? I want to know when this was created. So I'm going to pass the last one to be created at equal to, whenever this fund is being inserted, to get the current time of when it was created. So it's going to be funced on now, right? That's going to be the default value. And another thing that I want to do is I want to create a property for this funds table, right? I want to have a serialized method, so that when I do extract the funds from the database, it's in a format that I understand, or that is structured in a format that is readable or easily readable. So to do that, I'm going to do the at property annotation, and I'm going to give it a name of, I'm going to define a method of the name serialize, and I'm going to pass in the instance of self. And what I'm going to do is I'm going to return an object, and I want 3 fields. I want the ID, which is going to be self.id. Got to put a comma here. I want the amount, which is going to be self.amount. And I want when it was created, so created at, which is self.created at. Now, if you want to include the user ID, you could, but in my case, I don't necessarily need it, because I'm only going to be grabbing, when I do like query for, I'm only going to be grabbing data based on the user ID that I specify. So I already know the user ID when I make the request. So for me to grab the user ID again, it's kind of not necessary. And I need the ID for when I need to update a fund, so that's required in this case as well. So, but I don't need the user ID, because I already have it to retrieve the funds in the first place. So let's save this, and now we have the users and the funds table. But now we also need to establish the relationship of funds and users from the users table as well. So to do that, we can specify another field and call it funds. And I'm going to set that equal to db.relationship. And I'm going to open this up, specify the relationship is going to be with the table funds, and it's going to reference back. So I'm going to use a field called back reference back to users. So that's how we specify or create a one-to-many relationship between tables. You define the foreign key and define the relationship from the parent. So we're creating a relationship between the funds, between the user and the funds. So for each user, there can be many funds. Hope that was clear. If it wasn't, then go ahead and leave a comment. I'll do my best to clear up any confusion. So now that we have the models, we can now create the routes. So I'm going to create a file here called app.py and start defining the routes. Routes meaning, whenever we make a request to a route, it should do what we expect based on the HTTP method. So if you want to do a get, post, put, like these are routes that are going to handle those actions. So the first route that I want to do is I want to do sign up. Because that's pretty important, right? We need to define or create a user so that they can handle the other routes of creating, grabbing, deleting, updating. So we need an initial user to do that. And to create a user, you need to sign up. So we're going to need to reference this app variable to create a route. So what we're going to need to do is we're going to need to import that. So we're going to import, or from this parent directory, we're going to import app. Now all we got to do is use @app.routes, and all we got to do is define the name of the route. So we're going to do /signup, and for sign up, what we're trying to do is we're trying to send information of the user that's trying to sign up. So we're going to do a post. We need to handle post methods. So we can define the methods using the word methods and set that equal to pretty much a list of what we're trying to handle. So in this case, we just need to handle post. So we just put post in this list. And this is essentially a decorator. So what we got to do is define a method to handle the sign up. So it's going to be def and then sign up, open up the parentheses, and then within this function we can start defining the logic that we want to do when a person sends a request to this endpoint of /sign up. And what comes before the sign up is essentially where this application is being hosted. So since this is being hosted locally, and by default the port that Flask uses 5000, it's simply going to be when someone sends a post request on localhost 5000 /sign up, is going to run this code that we're about to define. And what is this app? Well, app is simply just this app that we use to create our Flask application, right? It's using this module name that we pass as a parameter and creating an instance of the Flask. And Flask just comes with so many different internal methods, and one of that is just .route, right? So we're defining a route and we're specifying the name of that route and the methods that this route can handle. Now, what I'm expecting to do in this route is I'm expecting to send a post request of JSON data. Now, to grab that JSON data, what we got to do is request.json, right? But I need to store that data somewhere, so I'm going to create a variable called data and make that equal to request.json. And it's saying what is request? Well, we got to import request from Flask. So from Flask, import request. Nice. So now we have access to the request that's being sent to this route. And what we need to do is we need to grab the expected attributes that we expect from this JSON. So, and I'm going to extract it by doing email equal to data.get email, because what we expect is we expect first name, last name, email, and password. So that's what we expect. So I want to grab all of that. So let me just cheat a little bit and copy and paste this 4 times or 3 additional times. And what we're going to do is grab the first name and specify that as first name, last name, and there's password. And to continue on, we have to make sure that every one of these variables are defined. So to do that, we can do an if, and if there's a first name, and if there's a last name, and if there's an email, and if there's a password, well, we can continue on with the logic. So now we need to actually start utilizing our ORM, right? We got SQLAlchemy for a reason. We need to communicate with our database. the first thing that's important to do when signing up a user is to check that the user didn't already sign up, because if the user already signed up, then we don't want to sign them up again, because remember, the email have to be unique, and if we try to insert somebody that's already there, then it's gonna break. So what we could do is we could filter based on the email that was sent in the sign up, and if something is being returned, then that means that user is already there, and that means we can't sign that user back up, and we can let them know you already have an account. We can't create another account for an account that's already created. So let's do that really quick. Let's do user, and we're going to set that equal to, and now we're going to see the magic of the ORM. So let's do users, and let's import that, right? So we actually need to import users from this models file, right? Because this is going to be how we create the users table using this model and the funds table. But this is also what we're going to use to query the database using the same model, right? So what we need to do is import that. So from dot models, import users, and I'm also going to import funds because we're going to need that in the future. And make some space here. And now we could do things like dot query and dot filter underscore by to define a filter that we want to filter by. So in this case, I want to filter by the email because we know that each email is unique. So if there's already an email with the email that we just got from the user that tried to sign up, then that means that user can't sign up again because we already have a user with that email. And we can do dot first to make sure that we grab the first instance of a user that already has that email. There's also dot all, meaning if we know that there's going to be multiple and we want all of them, then we can use dot all. But in this case, I just want the first instance. If we find just one person with that email, then we're not going to allow that person to sign up because that user already exists. So if there is a user, then we're going to return a response. And we can make a response by importing from Flask make response, which is going to help format a response to send back to the user. So we can return make underscore response and define a message, right? So I want to create a object or JSON structure of a key of message and an actual message. So please sign in. And I can also return a status code. So in this case, I'm gonna send it 200 because it's not necessarily wrong. We accepted the request, but you just got to make sure that you actually sign in because there's no errors on our case. We see that we handled the request properly. We checked if there's a user and we saw that there were a user with that email. So we can't create an account, but we will accept if you send a sign in, right? So go ahead and sign in with that same email. Now, if it doesn't find a user, then we can, actually begin the process of signing a user up. So we're going to do user is now equal to users. We're going to use that same model to insert into the database. So we're going to create a instance of user and add that to make a row in the database. So we're going to pass in email, and that's going to be equal to email. And we're going to pass in password, right? But like I said before, we don't want to just put password as the password, right? That'll be bad convention. What we want to do is we want to hash the password. What we're going to do is we're going to use a method from a security module to generate a hash of our password. So let's do that. So from workzog, I think that's how you pronounce it. I'm not even gonna try to act like I said it right, but .security, we're going to import generate password hash. And we're also going to need to check the password hash in the future. So we're going to do check password hash as well. We're going to import that as well. So we're going to generate it when we sign a user up and store that user into the database or the table. And when the user signs in, we're going to retrieve that user instance and check if that password is correct. So we're going to use this check password hash when we sign in. So stay tuned for that. And so for password, all we got to do is do generate password hash and pass password. And we should be good to go on that front. And then there's first name, which should just be equal to first name. Then there's last name, which should be equal to last name. Nice. And now add this user, and we have to commit this user, this new instance of user that we're creating into our users table. So what we need to do is we need to also import that DB instance, and also probably just do that in one line. So from the same place that app was created, we have DB, right? So with that, now all we got to do is db.session.add, and we're going to pass in this variable that's holding the instance of users, and we're going to do db.session.commit because we got to commit what we just added, right, to make it official. And we're going to return a response. So we're going to do make response, open that up, and I'm going to make another JSON, and it's going to be message, and it's going to say user created. And I'm going to do comma and pass in a status code. 201 means created, so I'm going to pass that. And for some reason, if all else fails, then we're going to return, and we'll do make response, and we're going to do a message of unable to, gotta be a string, unable to create a user. Put a comma, it's gonna be 500. And that is pretty much it. Pretty smooth. Grab the data, get the fields that we need. If it has the first name, last name, email, and password, query that. Grab the first instance if the email does exist within this table. And if it does, then just tell the user that you got to sign in. We already have somebody with that email because email got to be unique. And if not, then we'll create an instance of users using the model, hash that password, and then add that user and commit that user to be stored into the database. And then return response to let the user know that it was created. And if all else fails, then return this message to let them know that you were unable to create the user. Nice. So that is sign up. Now we got to do sign in. So let's do, just going to copy these two lines and then paste it down here. And it's just going to be login in this case. And I'm going to still be a post because they're going to send their username or email and password. And we just do login here. Same logic, I'm going to grab the request. So I'm going to call this auth, and I'm going to make that equal to request.json. And if there's nothing, so if there's not anything in the JSON, or not able to get the email, or not able to get the password, or you can do the same approach if making sure that it has all of them. But if you're unable to get any of these, right, then you just return a make response and just let them know that proper credentials were not provided. And you can set them for 1. Now we can use that method that we talked about before, which is called check password hash, and we can. And what that method is going to do is going to return true if that hash password that we're about to query the table for and the password that the user sent matches, right? So it's going to convert the hash password to an actual password that's readable, and it's going to compare it to the plain text that the user sent to this route. So what we got to do is do user is equal to users, which is that model that we imported, And we're gonna, against this model, we're gonna query and filter by the email that was sent. So it's gonna be auth.get email. And we, like I said before, we just want to grab the first instance, right? Because we just expect one, right? It's unique. We just expect one user with that email. And if there wasn't a user, right, then we're going to return a make response. And I'm going to let them know that they should please make an account. And that's going to return a full one status code. And if we're going to use that method here, it'll check password hash. And we're going to grab, because this is now holding a user instance, so an object, right? So we can do user.password because we know that's a field within the user's model, right? Password. So we can grab that. And that should now have the password of the user that has this email. And we're going to put a comma and compare it against the password that we just retrieved from the request. So we're going to get that password. So what it's essentially going to do is going to get this hash password, because remember we hashed it before, storing it into the table, and it's going to take this hash password, convert it into an actual readable text, and compare it against the readable text that the user just sent to this route, and it's going to return true or false. So if it's good, then we can send a token. So we're going to do token is equal to, and we're going to need to import JWT. So to do that, let's go above here and import JWT. Oop, import with a P. Go back down here, and what we're going to do is JWT.decode. It's going to generate a token, and we can pass in some values. So we're going to pass in ID, and we're going to pass in the user ID, because whenever a user sends this token with every request, we'll be able to grab the ID associated to the user that this token was generated for. Then we want to set a expiration date of this token, because tokens do expire. We don't want tokens to last forever, just in case it gets in the hands of the wrong person. So what we need to do is define date time so that we can define the expiration for this token. So from date time, import date time and time delta. Let's go back down. So what we're going to do is date time dot UTC now plus time delta, and we're going to set this equal to minutes is equal to 30. So this is going to expire, this token is going to expire for 30 minutes from now. And then after this decode, put a comma and set the secret. It's a secret, but in this case, we're just going to use the word secret, but this should definitely be more secure than the word secret. But you can generate some hash or something like that to generate the secret. But in this demo, it's just going to be the word secret, but it should be more secure. Just giving you a warning on that. And the type of hashing algorithm, so it's going to be HS256, right? So this is going to be, what we're going to be storing within the JWT, the expiration, the secret, which in this case is just the word secret, but it should be definitely more secure, and the type of hashing that this decode is going to be doing. And then after that, we can return make response. Let's do token and send the token. And we're going to put that as tool 1 because it was created. The user was created at that point, and if all else fails, we're going to return a make response and say, please check your credentials. Right? And it's going to be a 4-1. So meaning, if we are unable to get to this step of, the user sending a password and it was wrong, then that means their credentials were wrong. So you go ahead and check that your credentials were proper. Go ahead and send another request. So nice. So now what we need to do is create a decorator, because whenever a user sends a request, we want to make sure that a token is being sent with that request. But we did a lot of coding. Let's actually test if all this works first of all. All right, so one dependency that I forgot to install was this psychopg2-binary, and this is what we're gonna need to communicate with Postgres. So before going into the Flask shell, make sure that you pip install this dependency. So I already did that. So what I'm gonna do now is do Flask shell, and in this shell, what I'm gonna do is I'm going to create the tables based on the models that we created. So to do that, we can do db.create underscore all, and what it's going to do is going to create all the tables based on the models that are available. So if I go into dbeaver and I go into this Postgres database and I refresh and I go into tables, you can see that boom, it popped up funds and users, right? And if you have pgadmin 4, you can probably see the same thing. Or if you're using Postgres from the terminal, you can probably also see the data or the tables as well. But we can now see the tables based on the models that we created. We see ID, amount, user ID, and create at or created at. And then the users will see the ID, first name, last name, password, email, and created at as well. So now that the tables are created, we can now start to use the routes to create funds and create users as well. All right, so back in the editor, we can do quit to get out of the Flask shell and we can do flash run --port 8000 for me, and I gotta put the port and the dashes together. 8000 is for me, but if you just do flash run, it should run on the default port of 5000. So if 5000 works for you, then that's fine. But run on port 8000, press enter, and it should run our server. So we already have some routes that we can test. We have the sign up route and we have the login route. So I'm gonna go into Postman and try these routes out. So here in Postman, I already have some saved routes of, the routes that I used during my demo, but we can still utilize it to test the routes. So I can still use this post route and this post route for login as well, for sign up and login. And you just got to change the port based on the port that you use for your setup. And you can specify the IP, or you can use localhost here, whatever works here for you. So what I'm expecting is to pass first name, last name, email, and password to sign up. And if I press send, ooh, an error. So let's see. All right, so it's saying it has no attribute of commit because I misspelled commit. I forgot the I. So if I go up to sign up and I fix the I here, it's commit with the I, and I save that and I restart the server. Let's go back and test it out. And the URL pops up here. So if you need to take the URL for Postman, you can just grab it from here. All right, so back in Postman, send it again. Boom, user created. Perfect. And we even got the status code that we expect. And if I don't pass in first name, I'm curious to see what happens. Let me do that. Press send. An error occurs. So I mean, we can use a try and accept for that, but it does show a bad request. So technically, it's not too bad. But if you want to give it a specific name on bad request, then you can do that as well by using a try and accept. All right, cool. So let's go into login and make sure that I'm using the same email and password. Yes. So if I log in, also an error. So let's go and check. Instead of decode, it has to be JWT encode because we're creating the token, not decoding the token. We're not checking the token, we're encoding the token. All right, so let's run that again. Send it over, and boom, here it is, the token. So now that we have a token being returned to us, we can utilize this token whenever we need to make a request to any other routes that we intend to create in the future, because we're going to make those routes require a token. All you got to do is pass in a header. So it's going to be in the future, it's going to be like authorization, and you're going to have to pass in authorization. You're going to have to pass in this token value in this header. But it's going to get annoying to constantly have to copy the token whenever it expires, and we re-sign in to copy that token and paste it here. So what we could do is we can create a script to take that token value and place it in an environment variable that we can extract from, right? And the script is here. So in this test portion of Postman, what I do is I define this little script. So it's going to do pm.environment.set, and essentially what I'm saying is I'm trying to set this JWT variable to the pm.response.json, which is just this response JSON that's going to be sent back from the server .token. So it's going to grab this token from this JSON, and it's going to be the value of this token. So it's going to set that to JWT, and right here I even have an environment already created, and you can see that there is a JWT variable that's already populated with a current value, and that variable here we can use to place into the header. So all we got to do is do, and let me just bring that open, 2 curly braces JWT, and close it with another 2 curly braces, and it will grab that variable. As you can see, if I hover over it, you can see that it's showing that there's a value in current with the token value. So to create an environment, all you got to do is go to this environment tab here on the left and create a new environment, and you can give it a name. You can do whatever you want. So demo env is what I'm going to use, and there's nothing here, but if I go and I switch over to demo env and I go back to login and I log in again, if I open up the demo env, or I peek into it, I can see that JWT is now available and it's populated with the token. And if you want to go through it and double check that this is matching it, which it seems like it is, we can now have access to the JWT environment variable and utilize it in all our future routes by just using some curly braces and passing the environment variable name. So that's easy. So now we have easy access to extract the token, and now we can easily test our routes in the future. So speaking of tokens, we now need to create other routes and utilize this token to authorize a user to use those routes. But first, let's make a decorator for our routes to extract the JWT token on each request to verify that the user has the ability to do what's in the route. A decorator takes another function as an argument, which in our case is going to be the route of what we're trying to do for our fun. So that's creating, deleting, updating, and it's going to extend the behavior of the functions without modifying the logic within the main function. So in our case, we want to extend the function to verify the user before actually doing the rest of the logic. So let's do that now. Let's create a function, and I'm going to call this def token underscore required, because that's what I want. I want it to require a token, and I'm going to take in a parameter of f, which is going to be the function that we're going to be extending, right? And then use a colon, and I'm going to use the annotation of wraps, and I'm going to pass in the function that we passed into this token required parameter. And what this wraps annotation is going to do is going to add the functionality of what we're copying over, such as the function name and the doc string and the argument list, to the function that we're creating for this decorator. So let's do def inner. We're going to do it, create an inner function, and this is where the extended logic is going to be. So this is where we're going to check our token. So def, call this decorated, and what we're going to do is, so in cases where parameters are being utilized with the function, we need to accept those parameters in this inner function to make sure that we don't lose them when we're extending on to the function. So what we're going to do is use this asterisk args, and this double asterisk quarks. So it's just going to accept all of the parameters from the original function. And we can accept them. And what we're going to do is we're going to pass it back after we finish doing the logic for checking the token. So we're going to define a variable called token. It's going to equal to none. What we're going to do next is check if a token was sent with the authorization header. So if authorization and request dot headers token is not going to be equal to request dot headers authorization. Cool. Now if not token, if there's nothing in the token, then we can return, or we can make a response with a message. And we're going to say token is missing because you don't have a token. And make sure to send a 401. Cool. Now is where the logic happens, right? We're going to try to decode the token to make sure that it's a proper token. So we're going to do JWT, or data is going to be equal to JWT decode, because we want to get the information from the token if it is able to decode the token. So we're going to pass in the token as the first parameter. We want to pass in the secrets. And remember, this is not the best way to pass in a secret or define a secret. You should use a .env, and it should be way more secure than this, than just the word secret. But just for this demo, just for this purpose, I'm just using the word secret for my secret. But in this space, the second parameter will be the secret that you use to encode the token or to create the token. You're going to need the same secret to decode the token. So, and then for algorithms, just specify the algorithm that you use to create the token initially. So HS256 in my case. Now with this token, and if it is a proper token, then it's going to go to the next line. If not, then it's going to throw an exception, which we can catch using except, and the exception as E. And I'm just going to first print out the exception, and then I'm going to return a response. It's just to let the user know that we're unable to decode the token and it was an invalid token. And then we can send status code. I'm going to send a 401. Cool. Now back to this, right? So now that we have the token and extracted the information from the token, remember that there's two things that we place inside of the token. We place the user ID and we place the expiration date, right? So what I want to do is I want to check this current user, right? So I'm going to query based on the ID inside of the token. Now, if I'm able to query a user from the users table based on the ID that was inside of the token, that means they're a valid user, and to return the current user, right? So we could do users.query .filter underscore by, and what I want to do is I want to do ID because I want to query based on ID, and I'm going to say that equal to data ID, and I just want to grab the first instance of that user. I can even print out the user here just to test it out, and then after all this is done, we can return the function, right? But now with the parameters of the current user. So now it's going to pass the current user. So now whatever function that has this token required decorator will now have access to the current user because I just decoded the JWT. I queried the database based on the user, and I'm passing that now as a parameter. So now they have access to it. So if I need the ID or any information regarding the user, I now have access to it. And I'm just going to pass in the rest of the args that was from the original function. So I just got to use the asterisk again of args and quargs. And then after that, I'm just going to return the decorated, which is simply just the logic of the wrapped function. And I got to import wraps from func tools. So func tools, import wraps. Nice. So now we have a decorator that we just created that will go in, check the request.headers, check if it has authorization, check if it has a token. And if it doesn't have a token, then it's going to return a response that token is missing. And if it does have a token, then it's going to try to decode it, filter the database based on the ID. And if it does have an ID, then it's going to pass that as a parameter to the wrapped function. So now any function that has this decorator, that is wrapped by this decorator, will have access to the current user. So let's create a simple, or let's create the first route so that we can test this out. So what we're going to do is @app.route. And I'm going to call this route funds. And I got to bring this on the outside level. Okay, nice. Funds. And this is going to be to get all of the funds. So methods is equal to gets. And then I'm going to define the decorator. So token required. So anything that uses this token, or anything that uses this route has to have a token. And def.gets all funds will be the name of the function. And remember, now that we have the decorator, it's going to pass in a parameter every single time of the current user. So we can grab that by doing current user here. It doesn't have to be current user, the name, but just pass in a value that will store that current user. So I just to remember, I just name it current user. And any other parameter after that, you can just define it, you know, like this, right? Param2, param3, that's fine. But that first one is gonna be equal to the current user. And then now all we gotta do here for get all funds is pretty easy. We're just gonna have a variable called funds. We're gonna make that equal to funds.query.filter by, and open that up. And remember, we have a user ID field for funds. So I'm gonna make that equal to current user.id, because that's the ID of the user that sent the token, right? And we're gonna filter for all the funds that user have in the funds table. Remember, we create a relationship between users and funds. So if the user created a fund, then it should be in that table, and we should be able to query it by ID, by the user ID. And we're gonna use the .all to grab all the funds that matches this criteria, and that have that user ID that we specified. And we're gonna have another variable that has the total sum of the funds, because what we want to do is we want to return the funds as well as the sum of the funds. So, and what we can do is, if there are funds, so we can do if funds, we can calculate the total sum of the funds by making it equal to funds dot query dot with underscore entities db dot func dot round, because we want to round the value. And we're going to place inside of this fun.sum and funds.amount, because we want to get the sum of all of the amount of funds. And with this round, we want to make sure it rounds 2 places. And then the rest is just using filter to specify, you know, what funds we want to sum up based on what criteria. So we're going to filter by user ID, because we're just summing up the funds that match up that criteria. So it's going to be the same current user, the ID. And then we're going to use .all to get all the funds. And we want to make sure, because it's weird, like this query is weird, it returns like tuples. So we want to make sure that we get the values using, or we're accessing it using two access modifiers to grab the initial values. And we're going to see it when we print it out. I'll show exactly the structure that's being returned from this query. And just like we did before, I got to import from SQLAlchemy dot SQL import func. So now I should have access to that. Cool. So now that we got the sum, if there are funds, we can return response. So make response. I'm gonna open up this JSON right here. Then I'm gonna call this data, and I'm going to make a list of the funds. So for each row in the funds, I want to return the serialized data. Remember, in funds, we create a serialized method that returns the ID, amount, and created at of a specific fund, or for each fund. So we're going to make a list of each fund in that format. So what we're going to do is row.serialize for row in funds. So for each fund returned, return a row.serialize, or return the serialized version of that fund. If it makes it easier to understand, we could use fund. So for each fund, return a serialized version of that. That probably makes more sense. And then the second thing we want to return is the sum of all the funds. So total sum. Nice. Now, before testing this out, I want to actually make another route for actually creating a fund. So what we're going to do is I'm going to actually take all of this. Take this 3 lines right here. app.routes.funds, and then I want to do a post because I'm going to create. I'm going to still require you to have a token, but in this case, it's going to be create fund. And it's still going to send or it's still going to return the current user based on this token decorator. But in this case, now that I'm posting data, I want to grab the data from the request. So it's going to be request.json. And then if it has data amount, then fund is now going to be equal to an instance of funds. Like, we're going to utilize the model to create a fund, right? So we can do the amount is equal to data amount, and if you want to, you could just do, let me do amount is equal to data.get amount, and you could just pass, you pass this as amount. So if amount exists, then amount is now going to equal to amount here, put a comma, and user ID. We got to specify the user ID who's this fund belong to, and it's just going to be equal to current user.id. So that are really the only 2 required things for funds, right? Because created at is going to be created by default, and ID is going to be generated for us automatically when we insert into the table. So all we're going to do left is db.session.add. We're going to add this fund, and just because we added the fund, we still got to actually commit the fact that we're adding the fund. So it's going to be db.session.commit, and we're committing those changes. And what we're going to return is a serialized version of the fund. So the structure that we specified for the serialized method. Cool. So now we have a create, and now we have a get all. So let's restart the server. And let's see what happened here. So it says Flask object has no attribute of routes, because I misspelled this. It's supposed to be route. Nice. All right, let's run this again and go back to Postman. So like I said, I already have these routes created, and this is from the demo. So this is not what we have in the DB as we speak. So if I do get, it should now return a empty response of data, and the sum is now equal to 0. But if I do a post, right, and I'm going to set the value equal to 300, I'm going to send it, you can see now that it's just created one of the amount of 300 created at the current time with the ID of 1, because is the first amount or first fund that was created. And if I go back to get, you can see that it is retrieved and with the sum of 300. Nice. Now what I want to show for the, let me see, the sum, I want to show you the structure of total sum. If I don't use these access modifiers, right, it's gonna return a weird format. So let me show you. Let me print out total sum, and let me run it again, and let me send another response. So get, it broke obviously, but just to show you what it looks like, as you can see, it's returning a list of the type decimal and it's nested within a tuple. So to get the sum, what I would have to do is I would first have to access the first value within this list, and then access the first value within the tuple. So it's a very weird structure, but that's the reasoning for, using 0 and 0, because I'm going inside of the list, getting the first item in the list, and getting the first item within the tuple. And what I noticed is I could just use first here, and I actually want to see what happens if I do. I didn't try this before, so let me see. Gotta rerun that again. So if I run first, all right, it's still gonna be placed in a tuple, but now I don't have to use 2 access modifiers. I could just use 1, right? And this should work. And I'll just remove this comment. Save it. If I run it again, all right, boom, it works as expected. So now we have gets, and now we have creates. Now all we gotta do is do put and delete. So put is to update, and delete is what? To delete. So let's go down here, and I am gonna copy the first 3. And I'm gonna paste it down here. So app.routes, still gonna be funds, but I'm gonna now let the user pass an ID, because we need to specify what fund specifically are we trying to update. So it's gonna be ID, so to specify or to allow a user to place a value within the route. We can open up these, I forgot what they're called. I'm gonna say less than or greater than signs, and put the value of the variable within the middle of them, and then you can specify a name. In this case, I'm using ID, and to grab that value, you can just put here and pass it as the second parameter, because the first parameter is always going to be the value being returned by the decorator. So now we have access to the value that is being sent through the URL, and we're going to change the method to put, because it's going to be an update. So what we're going to do is we're going to try, and we're going to do funds equal to funds dot query, and we're going to do filter by user ID, and we're going to make that equal to current user.id, and we have to make sure that ID is equal to ID. So what it's going to do is it's going to get the current user's ID, but also we're trying to find a specific fund. So we're going to specify as a second search case, ID is going to be equal to ID, because essentially what this is doing is like a where, right? It's filtering where the user ID is equal to the current user.id, and where the ID is equal to ID. So it removes the need to have to use queries, but it still has that same structure, right? So now we just got to pass these values as a parameter. It's so easy to use an ORM, right? We don't have to think about writing a long query. This is all being done in the background. So then at the end, I'm going to do dot first, And if funds is equal to none, we'll return or make a response, and then that message is going to be unable to update, right? Because we're unable to make that update, so it's going to, and I gotta put this in curly braces, it's unable to make that update. Because there are no funds that match that criteria, we're unable to make that update. So then now we're going to grab the JSON, and we're going to do request.json, and we're going to get the amount. So we'll do data.get amount, because that's really the only thing that we have to update in this case. If there were other fields, then we'll grab those fields as well. But since amount is the only thing that we're trying to change, because we're not going to let them change the user ID. So the only other field that needs to be updated is the amount. And if there is an amount in the request, then we'll just do funds.amount, because we already have an instance of funds that was retrieved from the database. If there were no funds, or if there wasn't a specific fund that matched the criteria, then we will return that they're unable to make an update because there is no fund with that ID. But if there is, and we have an amount, then we're going to take that instance of that fund, and we're going to change that amount that's in this current instance of that fund and make that equal to the amount that was sent in the request. And then now all we got to do with this fund that we just changed is do db.session.commit to commit the changes that we just created in this. Now, if there were no changes, then there were no changes. That's fine. But if there were changes based on the amount that was sent, then it will commit those changes. And we can return a message. And in this message, it's going to be the serialized version of that fund. And I got to put this in a make response. And I'm going to send it with a 200 status code. And we can use accept, because we got to make sure if there are any errors while doing any of this, then we catch that exception as E. I can print out the E just for logging and return a response of error. Unable to process. And I'm going to send a 49. Nice. Cool. So now we have one more that we need to do. We need to delete the fund by ID. So we're going to go ahead and actually I've got to update this name right here. So that's, I got to do update fund. And I'm going to copy that on this new line. And I'm going to call this delete fund. We still need the ID because we need the ID of the specific fund that we're trying to delete. So we still need to reference that ID in the route URL and as well as the parameter. But we need to change the method to delete. So what we're going to do is same logic. We're going to try, and honestly I could probably just copy this whole thing really. That's what I'm going to do. So I'm going to try. So I'm going to try to query the funds to see if a fund exists based on the user ID as well as the ID that the user tried to pass. And I'm going to grab the first instance of that fund. There should really only be one, right? Because the ID is unique, as well as, the current user should only have one version of that. And if there are no funds that match that criteria, then it's unable to delete. Or actually you could say, let's do it on nothing. Or actually we can do, let's do something more enticing. So we're going to format it. So F to format the string, because we want to inject with, we're going to inject ID here, not found. And we're going to do 404 here. So message fund with ID, and it's going to inject the ID that they provided us. it's not found. So if they got funny and didn't provide an ID, well, it's going to be a nice little space there. But cool. And what we're going to do is now we don't even have to do all of this really. We can just do db.session.delete. And honestly, this should be singular because it's only going to be one. So I'm going to call it fund, and I'm going to do delete fund. So db.session.delete fund, and just to make sure that we actually wanted to do that, we're going to commit that deletion. And usually with deletions, you don't have to send a message, but I'm going to send a message of deleted, and I'm going to send a 202. And we can keep the exception message of unable to process if any exceptions occur. So now we have one for deleting, updating, getting, and creating. So let's go back to Postman so we can wrap it up. So we saw that we're able to get, let's see, and that's even perfect. We see that the token is invalid now because the time elapsed, right? So now it's returning a 401 unauthorized. The token is invalid, so we know that that works. So if I log in again, it's gonna give us a token again. If I do get again, it's gonna work again, because what it's doing is it's grabbing the JWT token based on the script that we created for logging in. Because when we log in, this script runs of getting that token from the response and passing that value to the JWT variable, which we're using for every single header for authorization. And now we're able to get, and if we want to post again, we're able to. So let me do another one. Let's do a bigger number of 2,000. Perfect. And if I get again, we can see that it's there now, and it's now equal to 2,300. Now if I want to do a put, I can do that as well to update the first value, and I'm going to make this also bigger, so I'm going to say 5,000. I'm going to put that. Oh, and something broke. Actually, I don't think I restarted the server, so let's see. So if and another test is we can see that how we formatted the user, because we're printing out the user somewhere. If I go maybe in here, yeah, I am printing out the current user. So we can see that based on the model that we created of user, we saw how if we print out the object of a user, it should print out the first name and the ID. Remember, I created my first name as Tech, and the ID of Tech is 1. So now we can see that the format of the user is as expected. This is how the object is going to be represented when we print out an instance of that object or instance of that class. I forgot to close it out as well, so it kind of looks a little bit awkward, but at least we can see that that works. But let me restart this to see if that helps, because I'm not sure if I did restart it. So let's go back and try to put. So back in Postman, we do put, and boom. Now if I go back to get, I can see 2,000, 5,000 is equal to 7,000, so that works. If I go to delete and I delete using the ID of 2, it shows the message deleted. And let's do get, and we can see that the second ID was deleted. So now all we have left is ID of 1 with the amount of 5,000. Perfect. So as you can see, we have a whole flow. We have a sign up flow, we have a login flow. We're able to get, post, put, and delete. We now have a fully running Flask application that is able to create, retrieve, update, and delete, a CRUD application. And we're able to utilize an ORM. So we use SQLAlchemy to create our tables, create relationships, and we're able to retrieve with no problems, communicate with the database no problem. We use Docker to create a Postgres instance, and we're able to save information to that Postgres instance no problem. Hope you found that useful. If you want more, or if you have any questions, leave it down below. Thank you.